Hello everyone, I'm Dr. J. Sirisha Devi, working as Associate Professor in Institute of Aeronautical Engineering College. Today we are going to see the basics and the introduction of data structures. I hope you guys are well introduced with what data is, right? So let's see, what do you mean by data? Can anyone recollect what you have learned earlier? What do you mean by data? Data is nothing but collection of information regarding some point, some issue, right? And coming to the computer's point of view, what do you mean by data? A collection of information placed in certain area, right? So what do you mean by data structure then? Placing the data in a certain fashion is nothing but a data structure. How to place the data then? Then there are many ways to store the data. In computers, coming to the computers, we store the data based upon the requirements. What purpose you are using the data for? Like we may be using the data for arithmetic logic units, that is to perform arithmetic operations, or in control units, or in memory management. Anyway, data will be used in database. We are going to store it, right? So data is retrieved and it will be used. Am I right? So when we retrieve the data and we use the data, so we need to store it first of all. So what are the different types in which we can store the data is nothing but a data structure. That we are going to learn in this whole session. Data structure is nothing but building a logical relationship between elements of data. For example, consider the data of yours. What will be data about yours? If someone asks you, tell me about yourself. So you'll be telling about your name, your father name, and your phone number, your email ID, right? Let's take these 4 basic points. In that case, your name, your father name will be alphabetic in order, right? Your phone number will be numerical in order, and your email ID will be alphabetical, but it contains special characters also. For example, @ is a special character. If your mail ID is having any dot, just like mine is having, so even that becomes a special character, right? So it is a collection of special characters also. It encompasses of, right? So different types of data will be there. So have to store this. There is a relation between the 4 data points which belongs to you, right? Your name, father name, your phone number, and mail ID. Is there a logical relationship between them or not, right? So data structure is nothing but the same. Storing this data in a fashion is nothing but data structure, right? Yes, that is data structure. Keep it aside. Let's talk about, we are talking about programming language, right? Let's talk about what is a program. What is a program? It is a syntactically correct set of statements or set of compound statements which when we are going to run it by feeding some input to it, you are going to get an appropriate output for the same. Am I right? So then that is a program. Then in that case, what do you need? What you are going to feed to it? You are going to feed data to it. Am I right? Then why we write programs then? The next question that raises is why we write a program. Program is nothing but a solution to a problem, right? Then that solution will be written programmatically to get the output, right? So for that, first of all, we go with the rough sketch of it. Rough sketch means, so what kind of data it is going to take, what may be the expected output of it, what is the logic behind it, right? So that is nothing but an algorithm. An algorithm is nothing but a solution to any problem which is been roughly defined, right? So a combination of a solution, nothing but an algorithm, plus an appropriate data structure suitable for that gives you a fruitful program which executes fast and which will help you out in getting a fruitful solution, right? So let's see what are the classifications of data structures. How far these data structures can be classified. Data structures can be classified broadly into two categories: primitive data structures and non-primitive data structures. What do you mean by primitive? Primitive data structures are like integer, float, char. All these are basic building blocks. We even call them as building blocks. Why we call them building blocks? Because they are the ones whose definition is already been defined in the compiler. Then what is defined in the compiler? The compiler knows what is the keyword which will be used to represent them, what will be the keyword, and what will be the amount of bytes will be required to store that variable of that particular data element, right? So say integer takes 4 bytes, float take 4 bytes, character take 1 byte, right? So it's already been defined. What is the keyword which represents that? Everything is defined. So when they are already defined in the compiler, we call them as building blocks or primitive data structures. On the shoulders of primitive data structures comes our non-primitive data structures. Taking primitive data structures as the backbone, non-primitive data structure come into existence. So they are broadly classified into two categories: linear data structures and non-linear data structures. Then what do you mean by linear data structure? Linear data structure is a data structure where data is stored in contiguous memory locations. Say, for example, if a data is placed in 200 location, then the next data is placed in 204, next 208, right? Next 212, like that, in continuous memory locations. When they are placed in continuous memory locations, we call them as linear data structures. Then how many types of linear data structures we are going to learn? Stacks and queues. These are the two types of basic linear data structures that we are going to learn in our coming classes. Then what do you mean by stack and what do you mean by queue? These all things we are going to see in our coming classes. But remember one thing, stack as well as queue are linear data structures, means data is stored in contiguous memory locations. Coming to non-contiguous memory locations. When we have linear, then why non-linear? The basic example for that is trees and graph. Then why we went for that? There will be cases where we cannot store the data in continuous memory locations. We have to skip because maybe huge amount of data is required to store and the system cannot find continuous memory locations to store such a huge data, right? So in that cases, we are going to store the data in a non-contiguous memory locations. That means the structure will not be in continuous manner. For example, the first data is stored in 202 location. The second one is stored in 315 location. Next, the third one is placed in some 412 location. Next is 95 location. Something like that. 195 say. Right? There will be a logical relation between them. There will be a link between them. Link will be there, which are going to say that the first data is at 202, the second is at 315, third is at 412, fourth is at 195, right? So, yes, you can see that the data is not stored in continuous memory locations. That is nothing but a basic example for that will be trees and graphs. How a tree will look like? There is a root node, it will have children, something like this, and these children will have children in this fashion trees. Can you see that? Is that the data placed within the nodes? Is it continuous in fashion? No, right? So this is about trees. What do you mean by graph then? Have you ever seen a graph? I'll show you. A simple graph I'm talking about is this one. Okay, let me build a connection between these two. Don't you feel that this is a graph? Each and every node, 4 nodes are there and 5 edges are there. Do you see any continuity between them? No. So even this kind of data we do have, right? So in that cases, we go for non-linear data structures. So as you can see, data structures can be classified basically or broadly into two different categories: primitive data structures and non-primitive data structures. Primitive data structures are the building blocks, like integer, float, and character, whose definition is already been defined in the system, and basic information like their reserved word, the keyword with which they will be called for, and the number of bytes they are going to use, right? And information about that. Non-primitive stand on the shoulder of your primitive data structures. So they are broadly classified into linear and non-linear, whereas linear data structures are the data structures where data is stored in continuous memory locations. Example for that is stacks and queues. And non-linear data structures where data is not stored in contiguous memory locations. Example is trees and grass. Okay, then let's see what operations can we perform on these data structures. So whether the data is stored in continuous memory locations or non-contiguous memory locations, we can perform some operations on that. We are not here to just store the data. We want to use it. Why we store the data? We want to use them, right? So what are the operations that we can perform on it? First and basic one is inserting a data element inside the already existing structure. So in how many categories we can divide this operation into sub-operations? Yes, we can divide it into sub-operations. For example, you can say that insert operations can be divided into three categories. For example, what are the three different categories? Inserting a data element as the first element, or the last element, or at a given position, right? At any given position, say the third element, fourth element, seventh element, right? So three different categories we have, right? Inserting an element. The reverse of that is deleting element. Just specify that. You want to delete the first element, last element, or an element at a given position. We can delete. Yeah, we do get these conditions like a case where a student wants to go out due to some reasons. He took TC and he wants to go out. Then obviously admin people will be removing the record on his registered number, right? So that registered number need not be the first one or the last one. It can be randomly placed at anywhere, right? So that is deleting a record or a data element. So basically for insertion and deletion, three sub-operations will be there. First position, last position, and any intermediate given position, right? Come to the third operation of your data structures. Third operations that we can perform is traversal. Traverse means traveling through one data element to the other element, right? You're touching each and every data item only once to check all the data elements, based upon whatever the size of the data structure may be. Traveling from one data element to the other element, from the first element to the last element, is nothing but traverse. Next comes the fourth one, sorting. What do you mean by sorting? Everyone knows it. Sort the data in either ascending order or descending order, right? From the largest element to the smallest element, or from the smallest element to the largest element, right? So this is nothing but sorting. Last but not the least one is searching for an element. We do search for records, right? We do that. So what our searching is nothing but trying to find a given record or key value. So these are the 5 basic operations that we perform on a data structure, right? Coming to the organization of data, as I have already said, data can be stored in 2 different ways: contiguous memory locations or non-contiguous structure. These are the 2 different ways we can organize the data in a data structure. Let's say, yes, we have seen what a data structure is, how it is classified, and what are the different operations that we can perform on a data structure, right? So what did I tell you? To get a successful program, to work with a successful program, you must be able to choose an appropriate data structure as well as a solution to that. What do you mean by solution? What did I tell you? Algorithm. Algorithm is a well-defined sequence or set of statements or instructions, right? Set of statements or instructions which collectively give a solution to the given problem. Is nothing but an algorithm. It is an Arabic word, algorithm. It has come from an Arabic word, right? So let's see what will be the structure of an algorithm. Basically, it has 5 steps. What are these 5 basic steps? The first step is an input step. Obviously, why input step? If you give some input to the program, then it will give you some output, right? So you need to, if for example, if you want to add 2 numbers, then the input you must give to the program is the 2 data values, right? It is nothing but the input. What do you say? Is it the input or not, right? So input. Then the step is output. The next is assignment step. What do you mean by assignment step? At times we need values. Inputs, okay. 2 variables you have taken. You need to feed some value to that. Assign some value to that, right? To perform the addition operation. Because our task is to add them, right? So that is assignment step. Next is decision making step. Decision step. At times we'll be forced to take a decision. Not always it will be a single streamline, right? So at times we need to take a decision between left or right, or you may have 4 directions when you want to reach your destination, right? So here also we will be forced to take decisions, right? Decision, when you take a decision, if you have 4 options, you'll be choosing only one out of them. Not all, not more than one also, I can say. Right? So, for example, let's take an example. For the given program, the input is the marks of a student. Okay, marks of the student in for 5 subjects. Now you have to, based upon the percentage, you have to tell to which grade that student belongs to. If his percentage is above 70 to above 70, he has passed, his grade will be A, first class with distinction. If his percentage is between 60 to 69, I'm not even touching 70. Okay. If it is between that, then I'll say that first class. Just first class. If it is 50 to 59, then I'll say second class. If it is below 50, that means 49 and below, I'll just grade it as fail, grade D. So A, B, C, D. So when I enter the marks of a student in 5 subjects and I calculate the percentage, his percentage will fall in any one of the categories, but not all. And it will not be in a student cannot get grade A and B. No, not even 2. It only 1, right? In that case, I'll be taking a decision-making structure. Decision-making control structure I'll be choosing to decide to which percentage has been calculated. The percentage falls in which grade category, right? So that is a decision-making step, and it is an optional. I cannot say that every program will be forced to have a decision. No, not at all exactly, right? At times, a program needs it. 4th one is repetitive. Repetitive means what? A set of statements which will be executed repeatedly. For example, I can give a very good example of calculating the table. If 5 ones are 5, 5 twos are 10, 5 threes are 15, and so on. I want to calculate 5 tens are 50. See, look at this one. For 5 ones are 5, the logic will be the same. 2, logic will be the same. What do you think? Are you doing the same operation or not? Are you doing the multiplication or not? Are you doing anything else? You are doing the same operation. But how many number of times? You are doing 10 times. What do you expect from me? I'm going to write this all 10 lines in my program. What if I try to extend it? I want a program not till 10. I want a program till 100. 100 times is equal to 500. Till then, if I want to do, am I going to write 100 lines of code? What do you think? Then is my program worthy enough to read or to understand? Obviously no, right? So in that case, I'm going to write just one line of code and I'll say that kindly repeat it for different values from 1 to 10 for 10 times. That will be concluded in just 2 to 3 steps. Don't you think that it is a productive one? That is nothing but your repetitive step. That means a compound statement, a simple statement or compound statement which is executed repeatedly. The same logic will be executed for n number of times. That is finite number of times. Then it is known as a repetitive step. Okay. So yes, even this step is an optional step. We cannot say that all the programs are going to use repetitive step. No. All the programs may not be using this step. It all depends upon the requirement, right? It all depends upon the requirement. But the most important step is the last step, output step. Every problem will have a solution, at least one solution. Can you say that? At least one solution we will have, right? So output step is a mandate step, just like an input step. So your program must be, in the algorithm which you write, must give at least one output. Yeah, it may give more than one output also, but at least one output must be there. Then only we can call that it is a well-defined algorithm. Okay, so understand this one. What will be the structure of an algorithm? The structure will be, it will have an input step, assignment step, decision step, repetitive step, and an output step. Then I said that it will be an algorithm which is worthy enough to be considered. Then what are the properties of an algorithm to say that it is worthy enough? So there are 5 properties of an algorithm which are going to decide whether it is worthy or not. First is finiteness. What do you mean by finiteness? Finiteness tells us about the solution of a given problem must be defined in a finite set of statements. In a finite set of statements. It must give a conclusion in finite set of statements. It should not be like repeating infinite number of times. That's why the word itself is finiteness, right? Second one is definiteness. They must be well defined. Unnecessary statements are not required while writing an algorithm. Just take a paper, pen, start writing on it. So what type of input it is going to take? What are the temporary variables it may want, right? With some initial values. And then what will be the hardcore logic for that? Is it going to use any decision? Is it going to repeat anything? What? Then what will be the output? That is enough. That is nothing but your definiteness, right? Each and every statement in your algorithm must be precisely defined. Next, generality. Algorithm must be generic in nature. It should not be confined that if this is the case, it will execute, it will work out, or else it will not give the solution. Every problem will have inputs from n number of categories, right? N number of categories. It's not that only one type of data will be fed. No, right? So then your algorithm must be generic in nature. It must be kind of a template which must be good enough to receive any type of input, right? So that is the generality of an algorithm, how generic it is. Next one is effectiveness, how effective it is. How effective. So whether it is basic enough to understand. That means, as I said, take a pen and paper, put it down, whether it is effective or not. Is it giving a solution to your problem or not? Right? So it must be effective in nature. Last property, but not the least one, which says that input output. It must take some initial input and it must give at least one output. At least one, as I'm saying, at least one. So if any algorithm which passes all the property, which encompasses all the properties of an algorithm, all the 5 properties of an algorithm, it is known as a perfect algorithm. Okay, so these are the 5 properties: finiteness, definiteness, generality, effectiveness, and input. Then, as I said, okay, 5 properties, then how can I measure it? How can I say you have written an algorithm for a problem? I have written an algorithm. Who is going to judge that your algorithm is better than mine? Right? Some parameter must be there. Yeah, parameters are there. 2 parameters are there to analyze any algorithm. One is time complexity. The other is space complexity. What do you mean by time complexity? Very simple. How much time it takes to run? Right? How many units of time your algorithm, when converted into a program, takes for an execution. Then at the same time, how many units of time my algorithm, when converted into a program, takes to get executed is nothing but time complexity. Next is contrary to that. The other side of the coin is space complexity. How much memory your algorithm needs to store. How much memory my algorithm needs to store. Why, how, space, a program. Are you talking about the space required to store the program, ma'am? No. I'm talking about how many variables you are going to use. What is the logic? To implement your logic, how many bytes are required? To store the variables you are taking, how many bytes are required? A cumulative of that. Right? The cumulative of that is nothing but a space complexity. So, the algorithm which gives a very less amount of execution time and which needs a very less space. In a comparative sense, I'm talking about between your algorithm and between my algorithm, right? Will be known as the better algorithm. Right? So time complexity and space complexity are the 2 parameters which are used to analyze the efficiency of an algorithm. Yes. Let's see an example for an algorithm. Yeah, you can see this slide in which I have presented an algorithm to add the individual digits of a 3-digit number. Say your number is 123. Okay, step 1 is start, obviously. Second one is read the value of n. You're going to read the value of n. Obviously, as I said, what is an important step and the properties of a good algorithm? It must take some input, right? So here n, capital N becomes the input. And sum is equal to 0 in step 3 is a temporary variable I'm going to take and I have assigned its value as 0. Then comes how long I have to repeatedly add the values. That means my purpose is to add 1 plus 2 plus 3. I want to perform this one and I give the answer as 6, right? So how many times I have to do that? Obviously, I have to do unless the value of n is greater than 0. Once it is equal to 0, I'm going to break it, right? So this is what I have to do. For this one, first what I'm going to do is calculate the remainder. Once you calculate the remainder, from the first step, what is the value that you're going to get? First is 3, right? So R is equal to 3. N is equal to 123. R is equal to 3. N mod 10. 3, right? And I'm going to add that to sum. Initially, the sum value is 0. I'm adding 3 to that, right? So the answer is 3. Now I'm going to store n is n by 10. That is 123 by 10. You're going to get 12, right? The latest value of n is 12 now. Again, in this one, algorithm, you can see that go to step 4. Again, go and check whether n is greater than 0 or not. If it is greater than 0, yes, it is greater than 0 because n is 12 now. Again, perform the same operations. R is equal to now 12 mod 10. You are going to get the value as 2. Again, calculate the sum. Sum is equal to what is the current value of sum? It is 3. Now, 3 plus 2, you are going to get 5. Right? Now, calculate the n value. N by 10. What is the current value of n? It's 12. 12 by 10, 1 you are going to get. Then it is saying go to step 4 once again. Is n greater than 0? Yes, 1 is greater than 0. Again perform the same step. That is 1 mod 10, which is 1. Now sum is equal to, what is the value of sum? What is the current value of sum? It is 5. 5 plus 1, which will give rise to 6. Now calculate the value of n. 1 by 10, which will give you an answer 0. Go to step 4 once again. Here n greater than 0 condition fails. Once it fails, it will take you to step 5. What it is checking for? It is checking whether n value is equal to 0 or not. Yes, it is 0. The current value of n is 0. Display the sum. What is present in sum? The value 6. So, don't you think that sum is holding a value which is the sum of individual digits of the given number, right? So, display the value of the sum. The result, that is the output of your algorithm. Stop. This is how you have to think. You have to think how to place the things properly in an appropriate fashion. And in this whole scenario, in this whole algorithm, come with all the 5 properties. Is it finite or not? Yes. In 6 steps, I have confined my solution. Is it effective or not? Yes, it is effective. We have just manually evaluated, taking a value 123. And is it generic or not? What do you think? If the value of n is 123, any value it is going to give the solution. It is generic in nature. It is definite. Yes, it is definite. Is it taking any input output? Yes, it is taking input 123 and giving me an output of 6. So all the properties of an algorithm are being totally justified in this algorithm. Okay. So guys, remember one thing. Your algorithm must contain the steps which are required. Unnecessarily don't write displays and unnecessary variables. To be a successful programmer, you must have some rough sketch in your mind how you are going to address your problem. When you try to put a pen on the paper to write the algorithm, you must have a rough blueprint in your mind. That means how you are going to address the solution of a given problem. I hope you got my point. In this session, we have seen an introduction of data structures, what a data structure is, and how many types will be there, how they are classified, what are the operations we can perform on it. And we have seen what an algorithm is, what are its properties, what is its structure, and we have seen an example for that one. This also, algorithms, right? So now you know what a data structure is, what an algorithm is. A perfect combination of these two will give you an effective program, right? With this, I conclude. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.